Okay, beta. So after a bit of okay, so after a bit of practice for the calculation, let's move forward towards the next part of this chapter, and the next part is basically called the acid-base equilibria. Okay, acid-base equilibria. In this section, we are going to do the definition of acids and bases. We get the concept of weak acid, we get the concept of diprotic acid. So this is all about acid and bases, which lead us towards the next part of this chapter, which is the acid-base titration curve. Okay, clear? So let's start with the basic definition of an acid. And in our course, the definition of an acid is basically, if you remember, हमने शुरू से definition क्या पढ़ी है acid की? क्या definition होती है? Proton donors or any solution that dissociate in water giving H positive ion. This definition is basically called Bronsted and Lowry concept. Okay, so this is called Bronsted and Lowry concept of acid and bases. Okay, these are the two scientists that gave this concept. Clear? According to that concept, the H positive ion donors are acids. Okay. In a similar way, H positive ion acceptors are bases. Okay. So just remember that the H positive ion donors are acid, the H positive ion acceptors are bases. Okay. Easy sa concept hai, it's not difficult. Let's suppose if we have a reaction of ammonia with H positive. Okay. And you know that the product is NH4 positive ion. You can see ammonia ने H positive को accept किया है. And H positive acceptors are base. That's why ammonia is a base. Clear? That's why ammonia is a base. Clear? Now, in a similar way, if I give you an example, like you have CH3 COOH, we all know that it's a carboxylic acid and it's a weak acid. Plus, if we dissociate into a water, giving a small amount of H positive ion and negative ion, which is CH3 COO negative. Okay? So you know that अगर हम AQ लिखते हैं, aqueous लिखते हैं, तो हम CH3 COO negative और H positive लिखते हैं. But if we show the dissociation by writing down H2O, तो हमें H3O positive लिखना पड़ता है. Make sure that you know that H positive aqueous is the same thing as H3O positive aqueous. It's the same thing. There's no difference. They are exactly the same. Now, as this is a reversible reaction, can you tell me why this is a reversible reaction? Because CH3COOH is a weak acid, and all weak acid dissociate partially by a reversible reaction. Now, in a forward reaction, you can clearly see the H positive is moving in this direction. Forward reaction mein, this is the direction for the movement of H positive ion. Agree, disagree? So can I say that this one is a H positive ion donor and this one is a H positive ion acceptor? H positive ion donors are acid. So this one is acting as an acid. H positive ion acceptors are base. So this one is acting as a base. Agreed? You can easily identify which one is acid and which one is a base just by looking at the equation. So this is all about the forward equation. Now let's do the same for the backward reaction. Now, in a backward reaction, you can see H positive is moving in this direction. So this is a H positive ion donor and this is a H positive ion acceptor. And you can see that the H positive ion donors are acid. So this one is an acid. H positive ion acceptor is a base. So this one is a base. Clear? Right? Now, there is a slight issue in this equation. Just look at the board. The issue is now we have two acids and two bases. Right? So how we can identify which of these acid is the acid of a forward reaction and which one is a acid of a or a base of a backward reaction. So we just slightly change the name. The acid or a base of a backward reaction is called conjugate base or conjugate acid. ठीक है इससे हमें पता चल जाता है conjugate means the acid and a basis of a backward reaction. ठीक है conjugate conjugate. Clear? Now if I ask you, can you write conjugate acid base pair? Can you identify the conjugate acid base pair? पहले तो बताइए conjugate acid base pairs होंगे क्या? Can I say that conjugate acid base pair 2? Molecules differ by H positive ion. देखिए कैसे ये बात अच्छे से समझ में आएगी. Let's do it now. CH3 COOH is an acid and its conjugate base is CH3 COO negative. What's the difference between these two? एक में H positive है और एक में नहीं है. That's called the conjugate acid base pair. ठीक है? Two molecules differ by only H positive. In a similar way, the second acid base pair is H2O and H3O positive. You can see the difference is still only the difference of H positive ion. So conjugate acid base pairs are the pairs that only differ by H positive ion. Clear? So again, this is the whole concept. According to the Bronsted and Lowry concept, the H positive ion donors are acids, H positive ion acceptors are bases. For the ionization of weak acid, you can identify in a forward direction, you have an acid and a base. And the acid of a forward is basically the base of a backward reaction. उसको हम conjugate base कहते हैं, which is technically the salt of it. Clear? In a similar way, this is the example number 1 of this concept. Can you do the example number 2 of this concept? And let me know which one is acid, which one is a base. And example number 2 is the example of NH3. NH3 plus H2O forming NH4 positive plus OH negative. Agreed? All these are, if this is basically, हम इसे liquid भी लिख सकते हैं, gas लिख सकते हैं, ठीक है? This is liquid and this is aqueous and this is aqueous. Can you identify the movement of H positive ion in a forward reaction? So can I say that the H positive ion is moving in this direction? Right? So this one is a donor and an acid. No? Base. Base. And this one is a donor and an acid. Okay, the first one is a base because it's accepting H positive ion. In a similar way, if you look at the backward reaction, the H positive ion is moving in this direction. Okay, this is the movement of H positive ion and this is the movement of H positive ion. Now, this one is a H positive ion donor. So this is a conjugate acid. And this one is a conjugate base. ठीक है, conjugate acid and conjugate base. And if I ask you कि जनाब write down the conjugate acid base pairs. Okay, so the first pair is NH3 differ by H positive with NH4 positive. ठीक है, एक ही मॉलिक्यूल की दोनों फॉर्म जो बोथ साइड पर हैं, जस्ट राइट इट डाउन इन अ सिमिलर वे H2O and बोले भाई OH negative. These are the conjugate acid base pair. I hope के the concept of conjugate pairs clear हुआ. ठीक है, डन. डन बेटा. Okay, there's something unusual in these two examples. One is the example of a weak acid, the other one is the example of a weak base. Ammonia is a weak base. Now you can see in these two examples, in this one water is acting, in this one water is acting as a, so can I say that water is acid or a base? Neutral? No. H2O is anything that can react with both acid and bases is called amphoteric. Okay, so water is amphoteric in nature because it can react with acid. When it reacts with an acid, it acting as a base. When it reacts with a base, it acting as an acid. So water is amphoteric in nature. Clear? One more last thing. Can you do this third example for me? CH3OH plus H2O reversible reaction. CH3OH2 positive plus OH negative. Okay. Now this is liquid. Water is liquid. This is aqueous. This is aqueous. Can you please identify the acid and a bases and conjugate acid base pairs for this given example? Now you do it by yourself and I'm doing it. Okay, H positive is moving this direction. Conjugate acid. Okay, and the conjugate acid base pairs are CH3OH, CH3OH2 positive, H2O, and OH negative. These are the conjugate acid base pairs. Okay. Now there are three terms. I'm not going into a detail of a weak acid. If I ask you what is a weak acid, you should know that the weak acids are those acids that dissociate in water, that partially ionize in water, giving a small amount of H positive ion. A strong acid that completely dissociate in water, giving large amount of H positive ion. I'm just going to introduce two more terms here that's normally they're asking in practical examination as well. The first term is called monoprotic. monoprotic or monobasic acid. Okay, clear? Monoprotic or monobasic acid, all those acids that give one H positive ion in aqueous solution. Okay, all those acids that give one H positive ion in aqueous solution are called monoprotic or monobasic acid. No matter it's a weak acid or a strong acid. Clear? So can I give you the example? HCl, HNO3, CH3, COOH. Okay. First two are the strong acid, the last one is a weak acid, but they all are the monoprotic acid. Why? Because if you write down the ionization of HCl, it will give you one H positive ion and one Cl negative ion. If you write down the ionization of CH3COOH in water, it is by a reversible reaction because it's a weak acid. Okay, so it will give you CH3COO negative plus H positive. So you can see both of these are giving one H positive ion. So that's why they are called monoprotic acid. In a similar way, we have diprotic acid. Hmm? No, it's only for acids. Why it is called dibasic or monobasic? Because it can just the top one, it can just neutralize 1 mole of OH negative ion. Monobasic का मतलब इसलिए हम इसे monoprotic का मतलब 1 proton donor. Now diprotic, as the name suggests, give how many? 2 H positive ions. ठीक है? And this one most common example is H2SO4. H2SO4. Because when H2SO4 get ionized in water, it's always give 2H positive aqueous ion plus SO4, 2 minus aqueous ion. Take better. So as you can see, 2H positive ions are, this is called diprotic. In a similar way, the last one is called polyprotic. Polyprotic or polybasic acid that give more than 2 H positive ion. Clear? And the example is H3PO4. The most common example, H3PO4. And the ionization of H3PO4 suggests is giving you 3H positive aqueous on incomplete ionization plus PO4 3 minus. You can see 3H positive ion, that's why it's called polyprotic. Triprotic भी कह सकते हैं, ठीक है? You can call this one as a triprotic as well. लेकिन polyprotic की term भी use होती है. Most commonly, it is called polyprotic, but you can call it a triprotic as well. ठीक है बेटा. So 1H positive ion donors or neutralize 1 base are called monoprotic. 2H positive ion donors or neutralize 2 bases are called diprotic, and 3 के लिए polyprotic और triprotic की term use होती है. Clear? Then beta, any confusion? Just a quick recap. Okay. We started with the acid-base equilibria, the Bronsted and Lowry concept of acid and a bases. They ask an exam, just write down H positive ion donors are acid, H positive ion acceptors are bases. And if I give you any chemical equation, no matter you know this equation before or not, you should be able to identify which one is the acid or a base of a forward reaction, which one is an acid or a base of a backward reaction. And you should know how to write down the conjugate acid-base pair. ठीक है, clear? इन सिमिलर वे बेसिस में भी ऐसा ही होगा. सॉरी, यस, बेसिस में भी आपको एसिड और बेस के कॉन्जुगेट पेयर आइडेंटिफाई करने होंगे. वाटर एक्टिंग एज एन एसिड with a base, water acting as a base with an acid. Water is called amphoteric in nature. बहुत शुक्रिया भाई. Water is called amphoteric in nature. ठीक है, क्लियर? इन अ सिमिलर वे, this is the equation which is unknown to you. मैंने आपको एक random equation दी है ना, and just by looking at the equation आपने देखा CH3OH से is getting converted into CH3OH2. It means that इसने H positive ion accept किया है, ठीक है. And then H2O से OH negative बन गया, यानी इसने H positive ion जो है वो donate किया. And then the concept of a monoprotic acid. Clear? The next topic is about the titration curve and acid-base titration. I'm not going to start it today. As I said, it's a complete lecture, so next session mein hoga. Let's start with a few questions. You remember the calculation हमने last time की थी? देखिए, as per the acid-base equilibria, this is the question. देखिए, it says which substance in 1 mole per dm cube of aqueous solution would give the same hydrogen ion concentration as 1 mole per dm cube hydrochloric acid. Okay, you have to compare anything with a hydrochloric acid. There are two things about the hydrochloric acid. Pehli baat, it's a strong acid. So the acid you're going to select must be a. So which one of these are the strong acids? Yes, sulfuric acid is a strong acid and a nitric acid. Plus HCl is a monoprotic acid. Okay, HCl is a monoprotic acid. So nitric acid is just like HCl, a monoprotic acid. Sulfuric acid kya hota hai? Sulfuric acid is a diprotic. So we cannot, it should give you the double the amount of H positive ion as HCl. ठीक है, तो sulfuric acid में आपको हमेशा H positive ion with the same concentration double मिलेगा. Clear? Any confusion in this one? हाँ हाँ हाँ, दोनों मोल पर डीएम की constant. They saying they, if you take the same concentration of HCl and the same concentration of any other acid, which acid give the same amount of H positive ion? So the acid you are comparing is a hydrochloric acid, which is a strong acid and monoprotic. फिर सल्फ्यूरिक एसिड होता आंसर. बिल्कुल ठीक है, हाँ, बहुत अच्छी बात है. If it would be 0.5 mole per dm cube, अगर यहाँ ये लिखा, the answer would be sulfuric acid, क्योंकि सल्फ्यूरिक एसिड का फिर डबल अमाउंट आपको मिलेगा. क्लियर? गुड. नेक्स्ट वन about a very simple equilibrium question. देखिए, this is the arrow here which is misprinted. It says vanadium compound that dissolve in water, the following equilibrium is established. ठीक है जी, and this is a reversible equation. My bad. Okay, what would be the composition of the mixture in the favor of V? What would alter the composition of the equilibrium mixture in favor of V2 plus? Means you have to shift the equilibrium towards left hand side. Now, the first, adding an acid. Now, if you add an acid, what should be the effect on the equilibrium? बोले बोले बोले. Acid react with OH negative ion. And if acid remove OH negative ion, the equilibrium will shift towards right hand side because more OH and ion should produce. Okay, so acid react with OH negative ion and shift the equilibrium to, but we have to shift the equilibrium towards left hand side. So this is a wrong option. Adding a reagent that selectively precipitate out V3 plus. इस statement का मतलब ये है कि you add something that react with V3 plus. In a similar way, H positive OH से react कर रहा था. So if you are adding something that react with V3 plus, V3 plus is on the product side, so the equilibrium again will shift towards the product side because you are removing product. Now this is the wrong option again. C, allowing the hydrogen to escape. If you allow this hydrogen gas to escape out of the system, means you are removing product again. So this is again the same concept, the equilibrium will shift towards. Making the solution more alkaline means you are adding more OH negative ion. If you add more OH negative ion, the equilibrium will shift towards left hand side in favor of V2 plus. So D is the right option. You got it? Okay, this one. Have a look, read it, and then we're going to solve. Partial pressure. Partial pressure क्या होता है? Moles of that gas divided by total moles multiplied by total pressure. The total pressure is 1 atm in this case. Can I do it? Again, let me try it. Okay. Equation is 2H2O forming 2H2 plus O2. ठीक है जी? It says it was found that 20% of the steam had been converted into a hydrogen and oxygen. And आपके आंसर्स में 1 और 0.1 और 0.2 नजर आ रहा है. इट मीन्स दैट कि इन्होंने जो इनिशियल कंसिडर किया है वो 1 0 0 कंसिडर किया. अब जब ये 20% डिसोसिएट हो गया, so it should remaining 0.8 after 20% dissociation. And you can see the molar ratio between this water and hydrogen is 1:1. 2:2 का मतलब 1:1. Means अगर 20% with 0.2 moles of H2O getting dissociated, the same 0.2 moles of hydrogen should form. है ना? And 0.1 mole of, because it is 2:1. Good. How many total moles are there? Total moles कितने हो जाएंगे? 0.8 plus 0.2 plus 0.1, which is 1.1. These are the total moles. NT में normally total moles को represent करता हूँ. अब मुझे बताइए कि partial pressure of H2O, the moles of H2O, which is 0.8, divided by total moles 1.1, multiplied by total pressure, which is 1. Partial pressure of oxygen is going to be 0.2 divided by 1.1 into 1. Partial pressure of hydrogen is going to be, नहीं ये oxygen तो 0.1 होगा, है ना? Hydrogen is 0.2 divided by 1.1 into 1. So which option is correct? Right option is hydrogen is 0.21. The D is the right option. ठीक है? अच्छा, अक्सर बच्चे इसमें जो है वो बी ऑप्शन करके आते हैं बिकॉज वो ये अज्यूम कर रहे होते हैं कि टोटल मोल्स तो 1 ही रहेंगे बिकॉज इनिशियली 1 लिए, बट द मॉलिक्यूल इज गेटिंग स्प्लिट इनटू 3 पार्ट्स, है ना? दो हाइड्रोजन और एक ऑक्सीजन. दैट्स व्हाई आफ्टर दिस द नंबर ऑफ मोल्स इंक्रीजेस, नंबर ऑफ पार्टिकल इंक्रीज हो रहे हैं ना आपके पास. ठीक है? क्लियर? सो if you write down the initial moles and you write down the moles at equilibrium, then find out the total moles and partial pressure calculate कर लें. 1.1 हो गए after equilibrium, because देखें 2 molecules 3 molecules में break हो रहा है ना as a result of a reaction. Number of moles क्या होता है? The number of moles is the number of molecules basically, and the number of molecules increases in a forward direction. Clear? Next, 11 critical question है. It says which statement concerning the equilibrium reaction below is true? An increase in the acid concentration will result in the increase in the concentration of Cr2O7. If you increase H positive, acid is H positive, the equilibrium will shift towards right hand side and you would have more Cr2O7. I think this is the right. Okay. So we're done with this one. Shall we discuss why the other options are wrong? Are redox reactions taking place? ऑक्सीडेशन स्टेट कैलकुलेट करनी पड़ेगी, करके देख लीजिएगा। अगर हो भी रहा है तो उसने कहा CrO4 2 minus 4 to the 8 plus 6 or Cr2O7 CrO4 2 minus Cr plus 4 times of minus 2 is equal to minus 2, तो कैसे है ना, तो Cr हो जाएगा plus 6, clear? Cr2O7 2 minus, so 2Cr plus 7 times of minus 2 is equal to minus 2. 2Cr is equals to plus 12. Cr is equals to, क्या ये redox reaction है? No, this is not a redox reaction because the oxidation state of chromium is exactly same. वैसे तो हमें सही आंसर मिल गया था, बट आपके डाउट की वजह से हमने इसको, ठीक है, ऑक्सीडेशन स्टेट is same. And that's the right way of identifying a redox reaction, that you should know कि हमारे पास जो है वो क्या चेंज आ रहा है. क्वेश्चन नंबर 16. In the contact process, ये भी done with this one? No. Sulfuric acid is mixed with, ठीक है जनाब. What effect the choice of condition for this reaction? A lower temperature would not raise the concentration of SO3 at equilibrium. At lower temperature 300, the vanadium penny. याद है आपको O levels में we used to say that in Haber's and a contact process, especially in Haber's process, a high temperature, a low temperature is recommended. Haber or contact process में, as the reaction is exothermic, we recommend low temperature. But a moderate temperature of 450 degrees is used, and we used to say that the temperature should not be very low, because very low temperature the catalyst become inactive and the rate of reaction decreases, slow down हो जाता है. वो स्टेटमेंट लिखा हुआ है यहाँ पर देखो. B option ही, at lower temperature of 300 the V2O5 would be not effective, है ना, effective नहीं रहेगा. V2O5 is a catalyst, so at very low temperature the catalyst become inactive. That's basically the idea. Or they ask the same question. So you done with this one? किया था हमने? नहीं. Okay जनाब, question number 19 की बात करें. 2NO2 forming 2NO plus. It says when 4 moles of nitrogen dioxide were put in a 1 dm plus and heated to a constant temperature, the equilibrium mixture contain itne moles of oxygen. Okay, what are the initial moles of NO2? 4. And what are the initial moles of NO? 0 and 0. कुछ नहीं बोला ना इन्होंने? Yes, good. At equilibrium, हमेशा इन questions को you have to solve it like this. At equilibrium, oxygen 0.8 moles. So 1:2 between oxygen and NO. So NO should be 1.6. 0.8 का 2. And how much NO2 should be utilized? 4 में से कितने माइनस करूं? 4 में से 1.6 माइनस होगा. क्यों? Because NO2 and oxygen is 2:1. So 0.8 moles of oxygen बनाने के लिए इसके कितने moles utilize हुए होंगे? 1.6. तो 4 में से 1.6 used up हुए होंगे, तो जो बचा होगा वो होगा 2.4. Clear? So at equilibrium 2.4, 1.6 and 0.8. Write down the Kc expression, which is 1.6 का square multiplied by 0.8. Agreed? Divided by 2.4 square, and the right answer is D. Got it? Have we done this one? Acha, there is a less chance of having a question related to this because this is not a part of syllabus anymore. वैसे common question है. For the equilibrium, this is the equilibrium expression, equation beta. What change, what will change the value of Kp? It should not be that long. It should be very quick. The value of Kc and Kp is only affected by temperature. These are the questions that you can solve in like within seconds. And these are the questions in which you have to save time for the other calculation based question for moles and for enthalpy and for equilibrium. Okay, do it. Calculate the value of Kp for this one. The partial pressures are given, already given. Question 23. The partial pressure is already given. Zero point A 0.33 square divided by 0.67. Simple. Very simple question. The equilibrium pressure, partial pressures are given, and just simply divide it and get your answer. Okay, good question. And this question mixed with the bonding. Okay, PCl5 dissociate as follows. The extent of dissociation is 13% at 160 and 100% and 300. As you increase the temperature, the dissociation, matlab the reaction must be endothermic. And what is the shape of PCl5? Trigonal, planar, or pyramidal? Phosphorus is in a group 5 of the periodic table. So this is the case of one lone pair and two bond pair. नहीं वैसे आपको नहीं ठीक है. So this is the same shape as ammonia, and ammonia is trigonal planar. Why? Phosphorus इलेक्ट्रॉन इन आउटर मोस्ट NH3 का शेप क्या होता है? तो PCl3 का भी सेम शेप होगा, पिरामिडल होता है ना, with a bond angle of 107. Okay, quick 26. 26. The question is A. ठीक है. So yes, we will continue equilibria. We are just holding it here, and then the last topic of equilibria, and then a few more past paper sessions for chemical equilibrium.